check?
No, not right now. You can touch it.
Okay.
We can touch it.
Okay. So, first off, I only want you to, on this assignment, I only want you to do the ones that are circled. Okay? So, on 35, the 35, that's that first circle in the top left corner of the 35 kind of word out. So, you're going to calculate E naught values for these reactions. Okay? Then, that's the only way you can do it. And then balance the reactions that are not already balanced, standard reduction potentials. Okay, that's basically what I'm saying. So you're going to calculate E naught values for these. Okay? And you say, hey, which one's reactions are spontaneous? Maybe both of them are, maybe neither one of them are. That's what you've got to find out. And then you're going to balance the reactions that are not already balanced. You can do the same thing on 36. Okay? So on both of those, you're going to calculate the E naught values, okay? Listen to me. You're going to calculate the E naught values, okay? And then balance the reactions. There you go. Now, when you get to question number 51, okay? You've got a whole bunch of different parts to 51. Now, let me point one thing out. When you get to 51, you have to pay attention to what you have available to you. Notice that you have sodium ions. You don't have elemental sodium. You have silver ions and elemental silver. Okay? You have chloride ions, zinc, and lead. So you have to pay attention to this. So on 51A it says, which is the strongest oxidizing agent? That obviously is only going to have one answer. Same thing on B, which is the strongest reducing agent? Again, you're only going to have one answer. But on C it says, which species can be oxidized by sulfate in an acid? Which basically means you're going to have hydronium ions. So to answer C, you're going to have to go to your chart, okay? And the whole key to this is which ones can be oxidized by sulfate. So you're going to have to find the reduction potential for sulfate in an acidic environment, which is what is listed. And basically you're going to say, hey, which one of these will lose electrons to the sulfate? Then on D, it says which species can be reduced by aluminum. Okay? So in other words, which one of these is going to take electrons away from the aluminum? Okay, that's the secret code on 51C and 51C and D. Are basically, so on C and D, you might have more than one answer. Okay? So because it says which can be oxidized and which can be reduced. So on A and B, you're only going to have one answer. On C and D, you might have more than one answer. Now, at the end of question number 1, it says give reasons for your answers. Okay? And that might be something is saying, well, with these reactions, I get a positive E naught value, so it's spontaneous. If you want to do the over-under explanation, I know this will happen because it's above or below this particular element on the reduction chart. Okay? I don't care, but you have to give some justification for all of those answers on 51. Okay? I'm done. You're on your own.